Hi everyone. In this video, I'm going to show how to sketch a quadratic graph and hence determine its domain and range. Here we have a 12 example. Some of the example we can use a transformation approach, and some of the example we have to use a completing the square to help us to sketch the graph. Here I'm going to show the example A. For this function of quadratic, I can use a transformation method to sketch this graph. That is, I start from the my basic graph, that is y equals to x squared. This parabolic shape is representing y equals to x squared. From the y equals to x squared, I'm going to sketch the graph of a y equals to x plus 3 square, where I can move, I can move the graph of x squared to the left hand side for 3 units. Okay, you can see this as a x minus 0 square. X minus 0 square meaning that it will passes through the 0 at the origin, and now if the x has been changed to the x plus 3, meaning that now the graph will passes through the negative 3. Okay, the minimum point will be negative 3, 0. Okay, so roughly the negative 3 will be here. Then I will move all my graph here to the negative 3, especially for this point, minimum point. I'm going to move this minimum point to the negative 3, 0. This is my x plus 3 square, which I sketch with the pink line. And you always can check whether this translation is it correct. You can check by substituting the y equals to 0. Substitute y equals to 0, you will have x equals to negative 3. So it is correct because the x-intercept will be at the negative 3, 0. So the basic graph of the y equals to x squared, you can just erase this off. Now, from this graph of a y equals to x plus 3 square, I'm going to sketch the graph of a y equals to negative of the x plus 3 square. When you have a graph, if you will multiply your y by a negative 1, meaning that now the graph will be reflected about the x-axis, meaning that the graph over here now it will be reflected about the x-axis and become like this. This side, when it reflect about the x-axis, you will have this. And then for the right hand side, the graph at the right hand side, this part, when it reflected about the x-axis, you will get the graph some sort like that. Okay, and now you can see that I have a y-intercept need to be find out. Okay, so I label this as a y equals to negative x plus 3 square first. Now I got to find the value of the y-intercept, but before this I just erase this off. Okay, so to find the y-intercept, I just need to substitute the x equals to 0. Okay, the function is fx equals to negative x plus 3 square. Substitute the 0 into the x, I will have 0 plus 3 square, which you will have 3 square, that is 9, and this you will get negative 9, meaning that this value will be negative 9. Okay, negative 9 will be the y-intercept. From here, I can find my domain and range. Okay, so for these two endpoint, you can always use a draw an arrowhead on it to show that the graph for this the graph at this endpoint will going to the left and going to downwards indefinitely, and for this endpoint, it going to the right and going to the down indefinitely. Okay, so to get the domain and range, I'm going to find the value which is closest to the left. To get the domain, this point will be the point which is closest to the left. Okay, so what is the x coordinate of this point? Since this point having the arrowhead over here, you know that this point, this end point is go to the left indefinitely. So we can use the negative infinity to represent its x-intercept, meaning that the domain is start from the negative infinity. And to get the other endpoint for the domain, I will search for the point which is closest to the right. This is the point which is closest to the right, and is x coordinate. I use the positive infinity to represent it, because this point there is no x coordinate. Why? Because it is going to the right, because the arrow shows that it's going to the right non-stop. Okay, or you may write your domain into the set form. This is the one. X is all the real number. To determine the range, I will find the lowest point at the graph. At this graph, the lowest point will be this 2 point. And these 2 point, you can see that it will going down indefinitely. So I will say that the y coordinate, okay, the y value to represent these 2 point will be the negative infinity. Okay, the y coordinate, because it has no y coordinate, because the point is just going down non-stop, so we use a negative infinity to represent the y coordinate belongs to this 2 point. And after that, I will find the highest point. This is the highest point of the graph. This highest point having the y coordinate 0, meaning that our range will be negative infinity up to 0. And at this highest point is part of the graph. That's why we use the close bracket to represent the function is include the 0. Or you may present your answer in the set form. That will be y less than or equals to 0, and you will have a y double dot, use a close it with the curly bracket. This will be the set form that you have. All right. For this question, we can't use the transformation. I have a two-step. We need to stick to 2 steps to sketch this graph. One of the step is using the completing the square. For the step 1, I'm going to determine its shape. Okay, we will extract the value of a. A is the value of is the coefficient of the x square, which is equals to 3. If your a is greater than 0, which is a positive number, then you know that your graph will be having the minimum point, and the shape of the graph will be open upwards. So for the step 1, we just need to determine the shape of the graph. Right? The shape of the graph either will be open upwards or open downwards. If your A is having the negative value, then you have the a shape which is open downwards and having the maximum point. So at the step 1, we only know the shape. So to know the minimum point which belongs to the function, we need to proceed to the step 2, which I'm going to use a completing the square. Okay, and to convert our function into this form, that is a x minus h squared plus k. When you have successfully changed your function into this form, then actually the a can give you the information of the shape of the graph, and the minimum point or maximum point will be given by this h and k. All right, if you have a minimum point, for this case you have a minimum point, then the minimum point will be given by, okay, you just change the sign of the negative h into positive h, and the y coordinate will be the k. The coordinate for the minimum point for this will be hk. So now we need to find what is the value of h and k. Copy down the function first. The first step we need to do for the completing the square is we must make sure the coefficient of the x square must be 1 first. So how do I change into the 1? I need to factor the 3 out. Never divide by 3. This is not an equation. Normally, student mistake, they divide by 3. And then they have a x square, okay, x square plus 4 over 3x plus 5 over 3, which is wrong because this is not an equation. So you need to factor out the 3. When you factor out the 3 still will be out there. And inside the bracket, you have x squared plus 4 over 3x. When you say factor out the 3, meaning that every term need to be divided by 3. So 4x divided by 3, you got 4 over 3x. 5 divided by 3, you have a 5 over 3. And now we can say that the completing the square, we can start now. But the completing the square procedure all will be done in this bracket. To do the completing the square, first I'm going to copy down the first 2 terms, and then put a bracket square minus bracket square. The constant I will put at the end here. All right. So you can see that now I just copy down the first two term over here and the constant term over here. Inside the in between them, I just add on a bracket square minus a bracket square. So now what is the value or what we need to fill in this bracket? We need to focus on the coefficient of the x. The coefficient of the x is given by positive 4 over 3. So we will insert the 4 over 3 inside here and don't forget divided by 2. Okay, 4 over 3, for positive 4 over 3 divided by 2. And now you have this as a 4 over you have a 4 over 6, which you simplify, you will have a 2 over 3. So this will become, this also the same, you will have a 4 over 6, and end up, you simplify, you will have 2 over 3. So now the expansion will become like this, okay, become like this. And now the first three terms of the expansion here, you can actually rewrite it into this form, x plus 2 over 3. Where I get the x, this is the one we just obtain the x, put the x over here, and positive 2 over 3 we get it from here. The square we put it outside. Okay, so when you expand this factor square, you expand it, you will get back these three terms. Okay, after that we need to simplify the constant term behind it. Okay, we have a 4 over 9 plus 5 over 3. Simplify this. Simplify, you will have this, and now you can multiply the 3 inside. You have a 3x plus 2 over 3 square. 11 over 9 multiplied by 3, you have 11 over 3. All right. Then compare with the standard form of the completed the square form, which is given by this. Fx equals to ax minus h square plus k. Meaning that compared with this form, you will see that the a is equal to 3, which will gives you the shape of the graph, and the h will be negative 2 over 3, k is 11 over 3. From here, you know that the graph is having the minimum point from the sign, okay, of the a value. So this minimum point will be given by this point, negative 2 over 3. Just take this value and then change the sign, negative 2 over 3. And then the y coordinate will be 11 over 3. Now you can start to sketch your x-axis and y-axis. Negative 2 over 3, you can now sketch this point. Negative 2 over 3 will be maybe somewhere here. Just estimate it. And then 11 over 3 will be somewhere over here. Okay, so the point of the minimum point will be given by this one. Okay, this point. After that, you just draw a sketch a graph with a open upwards, a parabolic shape, open upwards. All right, and this is the graph of the y equals to fx. And you can see that now the graph is passes through the y in y-axis that is called y-intercept. So this y-intercept you can find this value by substituting x equals to 0 into the function. Substitute x equals to 0. You have a 2 over 3 square plus 11 over 3. You got this as a 5. So this value, the y-intercept is 5. Okay, so from the graph, you can determine your domain and the range easily. You can draw an arrowhead over here at the endpoint to show that graph is going to the left and going upwards, and this is going to the right and going upwards as well. To get the domain, we can see that, okay, find the closest point, the point which is closest to the left. This is the point which is closest to the left. And since it will be going to the left indefinitely, so I'll use a negative infinity to represent its x coordinate. The same here for the point which is closest to the right. The x coordinate, I will use a positive infinity to represent it. For the range, I will find the lowest point. The lowest point of this graph is this point and having the y coordinate 11 over 3. So my range will be start from the 11 over 3 and include 11 over 3 and up to infinity. For this example, I'm going to use a transformation approach to sketch this graph because this function of quadratic just consists of a term of x squared and a constant. Okay, so we don't need to use completing the square method. We just use transformation approach to sketch this. So we start with the y equals to x squared. This is a y equals to x squared, which I draw it as a parabolic shape, and it passes through the origin. This is a y equals to x squared. From the y equals to x squared, I'm going to sketch y equals to 21x squared. Y equals to 21x squared. You can see that the coefficient of the x squared from 1 become 21. So the graph will be much more steeper compared to the y equals to x squared. It goes very fast, go up very fast. It still will be passes through the y equal origin, but the gradient is very steep. Okay, so this is the graph. The green graph is representing the graph of a y equals to 21x squared. After you have sketched this, the blue graph, you can just erase this off. And after that, I want to sketch the graph of y equals to 21x squared plus 3, meaning that from the graph 21x squared, I'm going to move up for 3 units to form a 21x squared plus 3. From the origin, the minimum point is from the origin. It is go up for 3 units. Okay, so this is a 3. Then you will have the same parabolic shape, but now the minimum point is at 3. Here I'm using the red line to represent it, and the green line you can just erase it off because it's representing 21x squared. Okay, so this you can say that this graph is a 21x squared plus 3, where the minimum point is 0, 3. Now, to determine the domain, we can see that the point which is closest to the left is this point, and it has a arrowhead over here to shows that this graph, this endpoint is going to the left indefinitely, meaning that you can use the negative infinity to represent its x coordinate, and the point which is closest to the right will be this point. Okay, and then you can see the arrowhead also. It shows that this graph is going to the right non-stop. So the domain is from negative infinity up to infinity. For the range, you must find the point which is the lowest in the graph. Okay, this is the lowest point in your graph. At this point, the y coordinate of this point is 3, meaning that your range will be start from 3. I use a close bracket to show that the graph is include the 3, include y equals to 3. And the highest point for this graph is these 2 points. You can see the arrowhead shows that these 2 points is going up. It's going up non-stop. So we use the positive infinity to represent its y value, and our range become 3 to infinity. So this is our answer. For this example, I'm not going to use transformation approach. I will take the step 1, step 2, which the step 1 is to determine the shape. You will consider the value of the a. A is equal to -1, which is less than 0, meaning that this graph having the maximum point. Okay, and the shape of the graph is open downwards. Proceed to the step 2. Step 2, we are going to proceed with the completing the square. When you want to do completing the square, you got to make sure the coefficient of the x square must be 1. So how can I make it into 1? I will factor out the -1, and then I have x squared plus 4x plus 5 inside my bracket, and the completing the square will be done inside this bracket. Firstly, I copy down the first 2 terms, and then I have my bracket square minus bracket square. The constant always put at the end. What should we fill in this bracket? We need to take the coefficient of the x. The coefficient of the x is 4. So taking the 4 divided by 2, positive 4 divided by 2, you will have 2 later on. Now, the first three terms here, it can be simplified into a factor square, a linear factor square, which is x plus 2. Where do you get the positive 2? You got it from here because the sign of this is positive. So positive 4 over 2 is positive 2. I just copy the positive 2 into here. And the constant, I just simplified it. 2 over 2, 4. 2 over 2, 4 over 2, 2. 2 power of 2, that is 4. Negative 4 plus 1, that is positive 1. After I have simplified, multiply the negative inside, you have this. Okay, so this is your fx. Consider the value of a here. You got a negative, right? So you got a maximum point. And the maximum point is given by the value over here, which you reverse the sign of the positive 2. You got the negative 2. And the negative 1 is over here. Means that your x coordinate and the y coordinate of the maximum point will be negative 2 and negative 1 respectively. After you have this information, you can start to sketch your graph. We plot the graph negative 2, negative 1 on our axis, negative 2, this is negative 2, and go down for negative 1. So this is the point which your maximum point, and the graph will be parabolic shape because this is a quadratic. And you can see that now your graph is passes through the y-axis. You have a y-intercept. To get a y-intercept, you just need to substitute the 0 into your x. You have negative 2 square minus 1. That is negative 4 minus 1. That is negative 5. Meaning that this value is a negative 5. Okay, so this 2 endpoint is going down, okay, indefinitely. From this graph, we can determine our domain. The domain, again, you can see your graph is going to the left and going to the right non-stop. So your domain will be negative infinity to positive infinity. And for the range, you will search for the lowest value, lowest point of your graph. The lowest point of your graph is this 2 endpoint, which the y value can represent by the negative infinity. And the highest point of this graph is this point, yeah? And it has the y value negative 1, meaning that your range will be up to negative 1. And this point is included into the graph, so you use the close bracket to close up the range. Okay, for this function, since it only consists of x squared, only one term of x squared, the other term will be constant. I'm going to use a transformation approach to sketch this graph. This is a very simple graph. We start from the graph of the basic graph. That is a y equals to x squared, which is a parabolic shape and passes through the origin, as if that this is your y equals to x squared. And you have the y equals to x squared plus 1, meaning that you are going to push up your graph 1 unit above. Okay, so from the origin, from the minimum point, originally is a 0. Now you will make it into the 1. You would move this point up the 1 unit, then it will reach 1 here. Then your new graph will become like this, the same parabolic shape, but the minimum point will passes through the 0, 1. Okay, so you the green graph, you can erase this off because this represents your basic graph. Then now, okay, you cannot label this as a y equals to fx yet because you haven't fulfilled the domain given. The domain given here is negative 1 to 3, meaning that at the x equals to negative 1 and the x equals to 3, you are going to cut down your graph using the dense circle because both of the value is included because I see the equal sign over here. So I'm using the dense circle to cut down my graph into 3 parts. Okay, 1, 2, and 3. Okay, but I will remain only the center, the middle part, because the domain given is from negative 1 to 3. The excess graph will be deleted. So now I highlight with the green color. And the dance circle also, I will use the green color to highlight it. Other than that, I need to delete. I need to omit. Okay, so just erase off the excess. Then you got your graph, which is required by the question. From the graph given, we want to determine the domain. I will find the point which is closest to the left. This is the point which is closest to the left, and get its corresponding value of x. It is -1, meaning that our domain will start from -1 and using the close bracket because this point having the dance circle. And you will find the next point which is closest to the right. This is the point which is closest to the right, and it has the x value 3, meaning that our domain is up to 3. And again, I use a close bracket to represent this is the 3 is included into our graph. Next, I need to find my range. The range, you need to find the lowest point. From your graph, you can see the lowest point is this one. This is your minimum point, right? So the minimum point having the y value, that is a y coordinate is 1, meaning that your range will start from 1. This is the lowest point that you have. And the highest point of the graph is this one. So the highest point of this graph, you need to find its corresponding value of y. When the x equals to 3, substitute here. When x equals to 3, the y is equals to 3 squared, that is 9. 9 plus 1 will be 10. Meaning that the highest point having the y coordinate 10. Y value is 10. So your range will be up to 10, and use a close bracket to show that it include this point, y equals to 10. So this is your domain and the range. For this example, it's a very simple example because the fx already present in the form of completed the square. Okay, you either can use a transformation approach to sketch the graph, or you will find a minimum point and then later on find the root, or if any, then you can sketch the graph. There is two methods that you can use here. Here I will I will find the minimum point or maximum point, depends on the value of a here first. Then I will plot the minimum point or maximum point on my graph. Okay, from there I will determine whether is there any root exists or not. If yes, then we need to find the root by letting the y equals to 0. From the step 1, determine the a. Step 1, the a is equals to 1, meaning that is greater than 0. This means the graph having the minimum point, or we say that having the shape open upwards. And for the step 2, I can determine the minimum point directly because this is already done, the completing the square. The minimum point will be -2, -1. So now we can start to sketch the graph. +1 minus 2, you got -1. The other roots will be x equals to -1 minus 2, that will be -3. So plot the x-intercept. X equals to -1. Okay, this is a x equals to -1. Your graph will pass through this point, and -3, you will have this. Meaning that your graph now will pass through this 3 point. That will be 2 x-intercept and 1 minimum point. All right, so this is your graph. Now, we have to check, okay, the domain is restricted from -4 to 1, meaning that at the x equals to -4, you need to cut down the graph by using the dance circle, because here we can see the sign over here is include the -4. So you need to use a dance circle to cut down the graph. And the graph is from -4 up to 1. So 1 is roughly here. Okay, let's see this. Let's say this is your 1, and you also need to use a dance circle to cut down the graph. Yeah, actually you have 3 parts of your graph. Your graph has been cut down to 3 parts: 1, 2, and the 3. Okay, then we only want to remain the center. Okay, the middle one. So after you have remain the middle part, you only have this graph. Okay, this graph passes through the y-axis, meaning that you need to find the y-intercept as well. Substitute the x equals to 0 into the function. You got a 2 square, that is 4, 4 minus 1, that is 3. So this will be the 3. Y-intercept will be 3. From the graph, you can actually label it now with the y equals to fx. So you can determine. So to find the domain, we find the point which is closest to the left. This is the point closest to the left, and it has a value of x is -4. So domain is start from -4, and we use a close bracket to show that this is include -4. And a point which is closest to the right is this one, and it has a value, the x value is 1, meaning that our domain is from -4 up to 1. Include the -4 and 1. To get the range, we need to find the lowest point of the graph. This is the lowest point of the graph, and it has a y value -1, meaning that our range will start from -1. All right, and the highest point will be this one. Okay, but the y we need to find first. When x equals to 1, to find its corresponding value of y, substitute x equals to 1 over here. You got the 3 square minus 1, that will be 8. Okay, the y value when x equals to 1, that will be 8, meaning that the highest point of the graph is this point, and it has a y value 8. So our range will be from -1 to 8 and include -1 and 8. For this function, -x squared plus 8, because the function did not state the domain, the special condition. So the domain from confirm will be from negative infinity to positive infinity, meaning that the x will be always all the real number. Okay, so this graph is very simple because we can sketch the graph by using the transformation approach, that we start from the y equals to x squared. This is a y equals to x squared. And now I want to sketch the y equals to -x squared. I just need to reflect the graph about the x-axis. I have this parabolic shape open downwards. Okay, this is your y equals to -x squared, and this can be erased off. Now, the -x squared, the graph of a y equals to -x squared plus 8, meaning that the graph will going up for 8 units. From the maximum point, 0, 0, go up for 8 units, as if that this is 8. Then our parabolic shape will be like this. Our graph will translate to the from this origin to the 0, 8. And all the graph, okay, all the point in the graph will going up for 8 units. So you can see that now you have the x-intercept, right? You need to solve for the y equals to 0. So solve the function. Let the y equals to 0 in order to get these two roots. When the y equals to 0, you have a -x squared equals to -8. And x squared equals to 8. So the x will be equals to the positive negative third of 8. Okay, square root of 8 can be simplified into 2 third 2. Nah? 2 third 2. So 1 will be the negative 2 third 2. Negative 2 third 2. The other root will be the 2 third 2. Okay, so now we have completed our graph. Since the domain is from the negative infinity to positive infinity, you can put the arrowhead to show that the graph is going down indefinitely. And to find the domain, we just say that the domain is from negative infinity to infinity. And the range, we need to find the lowest point of the graph. The lowest point of the graph, you can see that there is no lowest point. This can represent the graph is going down indefinitely. So the lowest point, we can just represent it with a negative infinity. And the highest point of the graph is the maximum point, where the y value is 8. So the range will be up to 8 and include the value of 8. For this function, since the function consists of x squared, x, and constant term, so I will proceed to my step 1 and step 2. Consider the shape of the graph first. Because of the a is equals to 1, which is positive, so I know that the graph is having the minimum point. And to find the minimum point, I need to proceed to the step 2 to do completing the square for the function fx. First thing we need to check is the coefficient of the x square. Since the coefficient of the x square is equals to 1, we can start our completing the square directly. Just copy down the first two terms and then put bracket square minus bracket square. The constant we just put at the end. So fill up the bracket by taking the coefficient of the x, that is positive 4, and divided by 2. Both are the same. The first three terms here, it can be simplified into x plus 2. The positive 2 come from here because the 4 over 2 is a positive 2. So I got a positive 2. Okay, and then is square the factor x plus 2. Then simplify the constant here. You got a 4 over 2, 2 squared, that will be 4. Negative 4 plus 3, that is negative 1. Now this is already done. You're completing the square. From this form, you can see that the graph is having the minimum point because of the a is positive, and the minimum point is given by the negative 2, negative 1. Yeah, from here, just to reverse the sign over here, you got negative 2, and the y coordinate is directly from this value, that is negative 1. So now you can start to sketch your graph in your axis. Plot your minimum point on the axis, negative 2, and go down for 1 unit, negative 1. So this is your minimum point. And if you sketch your graph, open upwards, you will see that your graph will passes through the x-axis, meaning that you got two different real roots. To get the two different real roots, I will take this function, the function in the completed square form, and let the f(x) equals to 0. Okay, let the f(x) equals to 0. You have negative 1 equals to 0. Then you got a x plus 2 square equals to 1. Solve for the x. You have x plus 2 equals to positive negative 1. Okay, set of 1, that is 1. And x equals to positive negative 1 minus 2. One of the x will be positive 1 minus 2, that is negative 1. The other one of x, the other root will be negative 1 minus 2, you got negative 3. So this is your negative 1, negative 2, and negative 3. The graph will passes through the minimum point, negative 2, negative 1. And it will also passes through the root, that is negative 1. And x equals to negative 3. Means that now your graph will passes through this 3 points. Just sketch your graph. You can see your graph passes through the y-axis, right? So to get the y-intercept, you can let the x equals to 0. Substitute x equals to 0 over here. You get a 0 plus 2, 2 squared, that is 4. 4 minus 1 is 3. So this point will be 3. And we need to check whether the question restrict the domain. Yes, the question restrict the domain into x less than or equals to negative 3 over 2. So we need to cut down the graph at the x equals to negative 3 over 2. That is roughly negative 1.5. Negative 1.5 will be somewhere here. Okay. So we need to, this is a negative 3 over 2. Cut down the graph by using the empty circle, because the domain given is x less than negative 3 over 2. It's not include the negative 3 over 2. So we just cut down by using the empty circle. Since the function wants the graph x for the x less than negative 3 over 2, we just remain the left hand side. And the right hand side, we just delete. So now I highlight with the left hand side with the red line. And this I just delete. Okay. Okay, this is a negative 1. Okay, so our graph is start from the negative infinity up to the negative 3 over 2. So you can label this as your y equals to fx. From the graph given, from the graph that we have sketched, you can determine the domain so easily. Okay, the domain actually is given in the question, that is from negative infinity. This is the point which is closest to the left, right? Since you see the arrowhead here, meaning that the graph is going to the left indefinitely. So this will be a negative infinity. Okay, and up to the negative 3 over 2, since the question, the domain given here is not include the negative 3 over 2. So you use the open bracket to close up the negative 3 over 2. And for the range, we need to find the lowest point of the graph. The lowest point is the minimum point where the y value is -1, meaning that our range will start from -1 and use the close bracket to represent this. The -1 is included into the function, and the highest point will be this point. You can see the arrowhead shows this point is going up. Okay, this endpoint is going up, meaning that our highest point will be represented by infinity. Okay, so this will be the domain and the range of the function. For this function, I'm going to use a transformation approach to sketch this graph, which I will start from the y equals to x squared, and then move your graph upwards for 4 units. From the origin, the minimum point from the origin, you move up to 0, 4. Okay, and then the same parabolic shape will be drawn. Okay, then you can say that this is your y equals to x squared plus 4 and erase off the green line. Now you want the domain from the 0 to 3. From the 0 to 3, so at the x equals to 0, I will cut down the graph, okay, using the Dan circle, because here you can see that the domain given here is close bracket, means that it include the 0. And up to 3, the 3 maybe will be roughly here. And then I will cut down the graph also by using the Dan circle. So the graph will be divided into 3 parts. Now you just remain the center, the middle part, because the domain is from 0 to 3. The excess you will delete it. You will delete the line that we draw. Now I highlight with the red line. We just want the red graph, and then we need to find the value of y when x equals to 3. When x equals to 3, you have 9 plus 4, that will be 13. So when x equals to 3, the y is equals to 13. You need this value for the range later on. Now, you can label this as your y equals to fx. So from this graph, you can determine the domain. The domain is from 0 to 3, is given by the question. Okay, and the range, find the lowest point. The lowest point is this one, and then this point having the y coordinate 4. So the range will start from 4 and use the close bracket to show that it include the 4. Yeah, and find the highest point. After that, highest point is this point, and it has a corresponding value of y, that is 13. So our range will be from 4 up to 13. For this function, 2x squared plus 2, there is no restriction on the domain, so the domain still will be negative infinity to positive infinity. To sketch this graph, I'm going to use the transformation approach to sketch the graph. First, I start from the y equals to x squared, which this parabola shape representing y equals to x squared, and then followed by the y equals to 2x squared. I need to sketch a y equals to 2x squared, which the y equals to 2x squared, the coefficient of the x squared is 2, which is higher than coefficient of the y equals to x squared. So it will be a little bit steeper, okay, a little bit steeper compared to the y equals to x squared, but it still will be a parabola shape and passes through the origin. So you can delete the basic graph, and this graph y equals to 2x squared is going to be going up for 2 units, okay, from the minimum point origin. Now you're reaching the 2, okay, the minimum point becomes 0, 2. So we sketch the y equals to 2x squared plus 1 like this. The shape still will be unchanged, but now the minimum point become 0, 2. As if that our graph is pushing up for 2 units. So this will be y equals to 2x squared plus 2. Now I delete the y equals to 2x squared. I have this. Okay, so this is the graph of a y equals to 2x squared plus 2. From here, because there is no restriction on the domain, you can put the arrowhead to show that the graph is going to the left and upwards and going to the right upwards. Okay, then to determine the domain, My domain is from negative infinity to infinity, and the range we need to find the lowest point of the graph. The lowest point of the graph is the 0, 2, and the y-coordinate of this point is 2. So the range will start from 2, and since you can see the arrowhead shows that the graph is going up indefinitely, meaning that the range will be end up with a positive infinity. So this will be the domain and the range. For this function, we're going to expand it first. We have a 2x squared minus 2x. Then I will go to the step 1 to determine the shape of the graph, since the coefficient of the x squared is 2, right? So we can say that a greater than 0. This graph is supposed to have a minimum point. And we proceed to the step 2 to determine the minimum point by completing the square. We complete the square for the function. Firstly, we need to factor out the 2 to make sure that the coefficient of the x squared is 1. Then now the 2 still will be outside. We will do our completing the square inside the bracket here. Okay, sorry, this will be the x, yeah, this will be the x. Factor out the negative 2, the 2 still will be negative x. And then after that, completing the square, just copy down the x squared term and the x term. And then we have a bracket square minus bracket square without the constant, because the function without the constant. What should we need to fill up inside this bracket is the coefficient of the x, that is negative 1, and then divided by 2. Taking the negative 1 here and then divided by 2. The first three terms in the expansion here, it can be simplified into this form, that is x minus 1 over 2 square, and simplify the constant, you get a 1 over 4. Multiply the 2 inside, you have a 2x minus 1 over 2 square. Negative 1 over 4 multiplied by 2, you get negative 1 over 2. So this will be in the completing completed the square. Then from here we can know that the graph is having the minimum point, and the minimum point is given by 1 over 2. From here, it reverse the sign of negative 1 over 2, you got 1 over 2, and the y-coordinate is negative 1 over 2. With this information, you can start to sketch your graph, which I'm going to plot the 1 over 2, negative 1 over 2 into my axis. This is 1 over 2 and negative 1 over 2. So my minimum point will be here. And I know that my graph will be going down and up like that. That's having the shape open upwards. Then my graph surely will pass through the x-axis, meaning that sure will exist a 2 different route. So to get the root, to get the 2 different root, I will go back to my question. My question function given, the function given already in the factor form, that is 2x x minus 1. Okay, 2x multiplied by x minus 1. In order to get the x-intercept or root, we will let the fx equals to 0. And now we can solve it easily. That is, we can get the x equals to 0 and x equals to 1, meaning that your graph will passes through the x equals to 0 and x equals to 1, and also the minimum point, this 3 point, it will passes through the 3 point over here. So now with this 3 point, you can start to sketch your graph. So this is a parabolic shape that I can get. And now scroll up. Okay, because the function given is that the domain is not restricted, meaning that we can just label this as a y equals to fx and put the arrowhead over the endpoint to show that the graph is going to the left and going up, and going to the right and also going up. Okay, so from here we also can determine our domain easily, because there is no restriction on the domain. So for the quadratic function, the domain always from a negative infinity to infinity if there is no restriction. For the range, we will find the lowest value of the graph. This is the lowest point of the graph. The lowest point of the graph is having the y-coordinate negative 1 over 2, meaning that our range will start from negative 1 over 2 up to the infinity, because the graph shows that it's going up non-stop. So our range will be end up by infinity. For this function, is given in the form of x minus 3 square minus 4, meaning that the completing the square already done, and the domain is restricted from 1 to 10, between 1 and 10, not including 1 and 10. So we can start sketch our graph by determine its shape. The shape of the graph, since the a over here is equals to 1, step 1, a is equals to 1, which is greater than 0, meaning that this graph having the minimum point. And the minimum point is given by taking the value of the, from here, that is -3, reverse the sign, you have a 3. Okay, you have a 3, and a -4 will be the y coordinate of the minimum point. So from this information, now we can start to sketch our graph. X-axis and y-axis, we label it first, and the minimum point given as a 3, -4, 3, -4, 1, 2, 3, 4, -4. So the minimum point will be over here. All right, and after that, we know that this graph having the minimum point, as we draw, if we sketch a minimum point, the graph in this shape, then we know that the graph surely will passes through the x-axis, meaning that it will have two different real roots. To solve these two different real roots, we can take this form and equate it to 0, meaning that let y equals to 0 and solve for the x. Okay, so you have x minus 3 square equals to 4, and x minus 3 will be equals to positive negative square root of 4, that will be 2. Then you have x equals to positive negative 2 plus 3. You have two values of x, that is two roots. One is taking the positive 2 plus 3, that is 5. The other one is x equals to -2 plus 3, that is 1. Meaning that your graph will passes through x equals to 1, yeah, this point, and also x equals to 5, 4, 5 over here. Okay, this is 5. So the 3 points will pass through by the graph. Now you can sketch the graph in a shape of open upwards. As we sketch our graph, you can see that the graph is passes through the y-intercept, y-axis. So you can actually find the y-intercept by substituting the x equals to 0. When x equals to 0, you got 9 minus 4. That is the y-intercept is having the value of 5. And scroll up to the question. We need the domain from 1 to 10. Okay, so I will cut my graph at 1, at x equals to 1. I put the empty circle over here because referring to the domain given, the domain is not include 1. So we use the empty circle. And then the 10, we need to lengthen our graph. Okay, you can see that I have lengthened my x-axis. Okay, my x-axis and my graph. So 10 is roughly over here. Okay, we say that the 10, this is 10, and also now I need to cut the graph using the empty circle because it's not include 10. Okay, so since the domain they want from in between 1 and 10, we just remain the graph in between 1 and 10. Other than that, we're going to delete. Okay, so we end up to have this graph. Then now you can label this graph as a y equals to fx, and hence followed by finding the domain. The domain is given by the question already, is from 1 to 10. And the range, you are finding the lowest point of the graph. This is the lowest point of the graph, and it has the value of y -4. So your range will start from -4 and up to the highest point of the graph. Highest point of the graph is this one. And the y value, the corresponding y value, you need to find the value of y when x equals to 10. Substitute 10 into the x. You got 7. 7 squared, 49. 49 minus 4, that will be 45. So this is the value of 45. Since the highest point of the graph having the y value 45, this means that your range will be end up with 45. And because it's not include the 45, because you can see the empty circle here to shows that this point is not included. So we will use the empty bracket to close up the 45 for the range. Okay, sorry, the domain, the domain shouldn't use a close bracket because it's given, is not include the 1 and 10. We just follow the question given. The domain is from 1 to 10, and you can see, you also can get it from the graph. Okay, so thank you for watching. For the next video, I'm going to discuss on graphing the cubic function and also determine the domain and the range from the graph.